Let's take a moment and talk a little bit more about details related to brain development. And the reason we want to talk about brain development and know a little bit more about some of these processes is that so many of the therapeutic activities that we use will be trying to take advantage of some of the principles of neurodevelopment. And as I mentioned earlier, a huge portion of development of the brain takes place in utero. In fact, the vast majority of the birth of neurons, in other words, the neurogenesis of these specialized cells, takes place in utero. The process of neurogenesis, it basically involves taking a precursor cell and having it divide, and then those cells divide, and those cells divide, and this graphic illustrates that remarkable process. Now, it is an astoundingly explosive process, so explosive that by the time you are in the third trimester, there are moments where you are making 20,000 brand new neurons per second. At birth, you have 100 billion neurons. In fact, 99% of the neurons that you use in your brain as an adult were present the day you were born. It's a remarkable process. Now, these neurons were present, but they had not yet completely specialized. Not only had they not completely specialized, but these neurons had really not moved where they should go. So brain development doesn't involve just a big ball of cells getting bigger and bigger and bigger. It involves specialized movements of unique neuronal networks so that, for example, the norepinephrine neurons that we talked about earlier or the dopamine neurons or serotonin neurons, they're born and then they literally move physically to the part of the brain that they will be most active in. So brain development involves neurogenesis, it involves migration of these newly born neurons, and then it involves a process of specialization. Not all neurons in the brain are the same. In fact, every single neuron in the brain is unique. You may get 10,000 neurons, for example, that use norepinephrine as a transmitter. However, if you take each one of those neurons, you'll find that they have a slightly different architecture. They have a different, if you will, structure. Some of them have long axons, some of them have short axons, some of them have lots of synaptic connections, some of them have a few synaptic connections, some of them send connections up into the cortex, and some send them to the diencephalon. Every single neuron in the brain is unique. And this is a remarkable, remarkable process. And the cells become unique even though they have exactly the same genetic material. Every neuron has exactly the same genes, but what is different is which genes get turned on and which genes get turned off. The process that guides that is called differentiation. And what determines what each cell does in terms of creating new synaptic connections or creating new neurotransmitter substances is really determined from the pattern of external signals. So during development of the brain, the signals that a neuron receives from its dendritic tree, the dendrites being these receptive portion of the neuron, the signals that come into that will tell the neuron what it should make. Are you going to be a norepinephrine neuron? Are you going to send connections to the cortex? Are you going to make a certain enzyme or not? And this process is very, very, very significantly influenced by experience. We talked about before how external experiences, talking with somebody, being held by somebody, looking in somebody's eyes will be essentially a neurobiological event. You take your sensory input and you turn it into patterned neuronal activity, and that involves the release of neurotransmitters, that involves a whole bunch of neuroendocrine and neurohormonal phenomenon, which in turn lead to the specialization of developing neurons. So in utero, prenatal exposure to cocaine, for example, which alters the release of dopamine, is going to therefore alter all of the target areas where dopamine neurons would normally be sending signals. Instead of getting just a little bit of dopamine, cocaine will cause a huge outflow of dopamine in these areas and therefore cause structural changes and later on functional changes in that part of the brain. So, intrauterine experiences can influence how neurons differentiate. The process of differentiation and the process of specialization in a neuron involves multiple complex neurochemical processes. One of the most important is what we call arborization. I mentioned these dendritic trees, and you've seen the images of these on the figures of the neuron. But you can have a very, very, very sparse dendritic tree with few branches, or you can have a very, very dense dendritic tree with lots of branches. And the density of this receptive field will depend upon the nature and the pattern of developmental experiences. So, for example, if you take a group of rats and you raise them in an environment where there are very, very few stimulating objects in the environment to manipulate, they just raise them in a cage. And then you look at the dendritic tree and their cortex. It's very, very sparse. But if you take rats and you raise them in an environment where there are other rats to socialize with, where there's little rat toys to play with, where there's opportunities to do rat locomotion, they get in those cages and run around, what you find is their dendritic trees are very, 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 very dense. Now, that is associated with increased functional capability. The animals that have this complex environment are actually more capable of functioning in complex situations that are new. The animals that are raised in cages are less capable of learning as quickly, and they have a number of other functional deficits and inefficiencies. We know that children raised in neglectful environments that are sensory depriving will have similar alterations in how their brain develops. So, for example, you will recall when we were talking about neglect that there were brain images of normal, healthy children who had, if you will, typically stimulating early developmental experiences, and then there were the smaller brains of the children who had significant sensory deprivation or environmental poverty. And part of the reason their brains are smaller is because they have much less dense dendritic trees. The same process can be said for the creation of synapses. And again, we've talked about the fact that therapy and education and development requires the creation of new synaptic connections. And in fact, when you talk with a child and when you hug a child and when you teach them a new motor task and you teach them how to self-regulate, what you're doing through your patterned, repetitive, nurturing, and enriching experiences is providing stimulation so that these synaptic connections can develop and can get strengthened. So, in utero, there's an explosion of cell birth. These neurons have not yet completely differentiated. They haven't sent out all the connections to where they're going to go. But after birth, what happens is there's this period from the first month all the way through the 6th month where there's this explosion of sending out synaptic connections. And these are, if you will, tentative explorations of what I could be as a neuron. And so a neuron will go out and it will send out a projection to an area where it's supposed to have some function. Let's say that it goes out to the speech and language area. And what it will wait for is patterned, repetitive experience to say whether or not you're going to speak English or are you going to speak Japanese. And each one of those languages has a unique set of neuronal networks that it will create based upon the sounds that that language uses to make associations with person, place, thing. So in some languages, there are sounds that you just don't use. So if those sounds are never heard by a young child, that potential capability slowly dissolves because you lose that tentative synaptic connection. That process of synaptic sculpting is most dramatic when you are young. So the most synapses you will ever have is at about, depending upon the brain area, between 3 and 9 months of age. And from that period forward, the process of creating new synapses and resorbing synapses that you don't use has a rough equilibrium. So the process of acquisition of a new skill, as you grow up requires the connection and the creation of a new neuronal network. And certain capabilities, certain experiences that you may have had earlier in life that you're not practicing, you will slowly resorb. Everybody has probably heard about the fact that elderly who have physical activity, who have social activity, who are cognitively active, end up becoming demented much later in life. That's because they are having pattern repetitive practice in all of these neuronal networks and maintaining synaptic connections and maintaining function. So people who stop reading, who stop playing games, who stop socializing, who stop being physically active will literally have a gradual reduction in synaptic connectivity in emotional, behavioral, cognitive, and motor domains, and you start to lose function. It really is a use it or lose it proposition, not only during later life, but it's the very nature of development. That if you take these potential capabilities and you do not get practice, and you do not get pattern repetitive stimulation of these neuronal networks, those systems will not be maintained. And again, this is the molecular mechanism that underlies many of the things that we see in neglect. A child who's not spoken to will not get sufficient stimulation in this potential speech and language connection to maintain it. And they will lose the capability of speech and language. Children who do not have consistent, predictable, nurturing, and loving interactions will not get sufficient repetition in the part of your brain involved in forming and maintaining relationships. So you can have children who are institutionalized in very resource depleted, relationally impoverished settings, where and we've worked with children, for example, who have been one of 80 children in one room, where they will sit in the same crib from birth until age 4 or 5, and they will have a caregiver who will come and feed and diaper them, and the experiences of this child are impoverished in cognitive domains, in social emotional domains, in motor opportunities. So what happens is these children have all kinds of potentials that remain unexpressed. The key question is, once they're taken out of that setting and you put them into an environment where there are opportunities for motor exploration, for healthy relational interaction, for cognitive stimulation, can you recapture that potential? Now, we used to be much less optimistic about this than we are currently. And I can tell you that a core aspect of this neurosequential model of therapeutics is using the built-in gifts of neurodevelopment to take advantage of opportunities for re-expressing untapped potential. The challenge of that is, of course, that our current intervention models are not very developmentally informed. And part of what we hope to do with this series, and part of what we are doing in our ongoing work at the Child Trauma Academy, is creating a set of developmentally informed interventions and approaches to children who've been neglected and maltreated. Let's talk a little bit more in detail about the sequential development of the brain. And the reason that we should talk about that is that when we talk about educational, therapeutic, and caregiving interventions, we're going to remind you again and again and again that if we do not meet children where they are developmentally, we will always be inefficient in what we're trying to do with these children. So, going back to the upside-down triangle model of the brain, you remember that very simple image where there were 4 major areas. There's the cortex, the limbic, diencephalon, and brainstem. And next to those areas, I put functions. So, abstract cognition is a function mediated by the top part of the brain, the cortex, and regulation of heart rate and blood pressure is a function mediated by the lower brainstem area. Most of you appreciate that there are more than a handful of functions that the brain mediates. So what we have done in our creation of a functional map of the brain is to divide the brain up into little pixels, little boxes, and place those functional boxes that correspond to a specific function, into the part of the brain that mostly regulates and mediates that function. So instead of having 8 or 9 functions, we actually are able to come up with 60 or more functions. And if you look at this map that we are showing in this image, you'll see that there are these brainstem related functions, there are diencephalic or midbrain functions, there are limbic, and then there are cortical functions. And this is a tool that we use to look both at development of an individual child and to look at the sequential acquisition of function. So under normal circumstances, if you look at a healthy newborn infant, they will have certain cortical functions, like abstract cognition, for example, that just aren't present. So that capability is undeveloped and not present at birth. This is indicated in this graphic by a lightly colored box. In contrast, the ability to regulate body temperature, which is brainstem mediated, is present at birth, and it needs to be present at birth or the baby would be in big trouble. So what you see in this is that brainstem mediated functions develop primarily in utero. Now this is really important clinically. Intrauterine insults like alcohol or extreme distress for the mother or methamphetamine will result in significant abnormalities in the development of brainstem mediated functions. And we talk about later on, and we talk about throughout this series, about the importance of these brainstem originating neurotransmitter systems involved in stress, arousal, attention, relational health, and so forth. Noradrenergic, dopaminergic, serotonergic systems develop in large part in utero. Now, very important things do happen later in life in their differentiation and their specialization, but fundamentally the brainstem organizes in utero. And if you don't have a well-organized brainstem at birth, you are going to be a very, very, very fragile child. So those of you who are familiar with what happens with preemie babies, these little creatures cannot regulate their body temperature. They can't regulate complex sensory environments. They have difficulties with arousal and attention. They have an increased startle response. They have respiration and cardiac problems. So in part, it's because their brain is immature. And all the brain-related functions that are brainstem in origin need to be sustained until the brainstem can organize. All right, so this is what you'll see in a healthy newborn. Pretty well organized brainstem functions and emerging diencephalic functions. Some capability for precursor to relational connection. In other words, they're very, very, very receptive to creating a healthy relational connection, but it's not present. It's not fully organized, it's not fully elaborated, and it is waiting for a human being to act as a template against which they can organize. And as we talked about earlier, if this caregiver is attentive and attuned and responsive, those systems will develop one way, and if the caregiver is absent or hostile or depressed, those systems will develop in a different way. So, a year later, this is what a functional map of the brain looks like. The child has built in many, many more capabilities, and there are more emerging capabilities. The capacity for certain kinds of fine motor and large motor skills are emerging. The capacity for more complex relational engagement and communication are emerging. The capacity for certain cognitive tasks are emerging. And what I'll show you in the next sequence of images is how you can create a functional map that tracks out the development of the brain in a sequential way, from the bottom to the top and from the inside out. And again, remind you that the development of a higher part of the brain depends in part upon signals coming from lower parts of the brain. So if you have a well-organized, synchronous, rhythmically smooth lower part of the brain, you will get synchronous regulating signals that help the structural organization of higher parts of the brain and help the acquisition of a function related to that brain's organization. Year 2, year 3, a 4-year-old, and what you can see is, look at how much of the brain is organized in the first few years of life. Now, it doesn't mean that it's completely developed. It doesn't mean that it's completely manifesting every aspect of what the brain can do, but the fundamental organization of the brain is put in place in those first 4 or 5 years of life. And you can see when you look at brain-mediated functions, either the actual function or a precursor function are present by the time you're 4 or 5. If you take a functional map of a healthy child at a given age, and then you do the same kind of assessment of the functional strengths and vulnerabilities of a child who's struggling, you can come up with some very, very interesting comparisons. And I will show you a series of images that illustrate this process. And the first one is a comparison of a healthy newborn who has a relatively well-organized brainstem with a newborn who has fetal alcohol syndrome. In utero, exposure to alcohol can be tremendously destructive. And it obviously depends upon a number of factors, how much alcohol, at what time during development, and so forth. But in this specific case, this was a child who was born after relatively heavy drinking throughout the majority of the pregnancy. Children who have this kind of developmental insult frequently have very poorly organized self-regulation capabilities. They're difficult to soothe. They have difficulties with a suck and swallow. They have difficulties regulating body temperature. And in many ways, they're very much like a premature infant, even though they are full term. So the key to understanding how to use these functional maps is in recognizing that in order to help a child develop, in order to help a child move from one stage of development to the next, in order to take an emerging capability in one part of the brain and provide the pattern repetitive experiences to help it fully organize normally, you have to meet the child where they are developmentally. So this newborn with fetal alcohol syndrome developmentally is like a preemie. A newborn baby can tolerate sensory complexity. This child with fetal alcohol syndrome can't. And you can see that by looking at their functional inability of the brainstem for certain kinds of sensory integration and sensory processing. So what this tells us is that we cannot parent that fetal alcohol syndrome baby the same way we parent a healthy child. If you have the normal introduction of the baby to the world, the way we typically do it, and there's a little bit of social complexity and there's a little bit of change in schedule, and that can be tolerated by the typical infant. But this infant will be completely overwhelmed by any sensory complexity, by introducing any new caregivers. This child will be difficult to soothe even with his experienced, comfortable, confident primary caregiver. Imagine how overwhelming it is to introduce a child like this to multiple caregivers, all of whom might be frustrated by the fact that he's crying and irritable and doesn't eat well and all of the things that go with having this poorly organized brainstem and essentially a brain that is not yet prepared to learn how to self-soothe. This is a really significant challenge. What happens, therefore, is if you have a mother who's been drinking, a mother typically has been drinking and struggling, a mother who I'm sure is very often knows that this is bad for her baby but can't stop anyway, combined with a difficult to parent and difficult to soothe infant, it is a toxic combination. So what will happen is, rather than getting the developmentally matched experiences, this child is at risk for having that sort of dysynchronous, episodically overwhelming, episodically potentially abusive interactions. And we see this all the time. The other thing that's very, very challenging about children who have these developmental gaps, so to speak, is that when they grow up, they chronologically get older. But because we're not meeting them where they are developmentally, they don't mature in these lower systems. So you can end up with a child like this, for example, who's 2 years old. This is a child who's been significantly neglected. If you recall those brain scan images of the normal sized brain and then the smaller brain, this is a child who had a similar situation, significant early sensory deprivation. Now, at 2 years old, this child was about the height of a normal 2-year-old, a little bit smaller, but not markedly smaller. He was in foster care. The foster parents didn't know that much about his background. So they have a little 2-year-old child who kind of looks like a normal 2-year-old. They've been parenting children. They raised their own children. They're relatively new foster parents, so their expectations are that if you look like a 2-year-old, you sort of stand like a 2-year-old, the records say you're a 2-year-old, I'm going to parent you like a 2-year-old. The problem is, if you look at his functional map, he's got a brain that's essentially very much like a newborn. So rather than having experiences that a 2-year-old can tolerate, and actually a 2-year-old needs for that 2-year-old to leave his comfort zone and get into his developmental hot zone and actually get the practice and acquire new skills, if you have that same set of expectations for this 2-year-old, they'll be overwhelming. It's a complete mismatch between what he can do and what the world expects him to do. So this child came into our clinic, foster parent complaining that this little child is always clingy, always wants to crawl into my lap, always wants to be rocked at night, wants to be fed like a baby, wants me to hold him all the time. And the feedback that the foster parent is getting from her husband and from her neighbors and from her mother, make this kid grow up, make him act his age, don't baby him, don't spoil him. The fact is, her gut feeling is, I want to do this. And the reality is, she was right. This 2-year-old child has the brain and the developmental capabilities of an infant. If you want this child to catch up, you have to meet him where he is. And you have to provide pattern, repetitive, somatosensory experiences that would be more typical of what you do for an infant. But without those, these lower systems won't organize. They'll never organize. This child will just get older and older and older, and the gap will be even bigger, and you'll end up with something like this, which is a 6-year-old who's got a history of both neglect and trauma, and what you see is this sort of scattershot development. Some things are present and seem to be okay. Other things are completely absent, and this child is a mess. He's got impulsivity, he's got attentional problems, he's got behavioral problems, he's got social problems, he's got fine motor control problems, he's got gait problems, he's uncoordinated on the playground, he can't get along with peers, he can't do well at school, he's getting negative feedback from the whole world, and he feels crappy about himself. I'm stupid, I'm bad at sports, I don't have any friends, nobody loves me, nobody wants me. And so what we have is a child where there's been this long history of disconnect between what he could physiologically do and what the world expected him to do. So the opportunities for him to acquire new skills were basically disorganized, dissynchronous with where he was developmentally, and ultimately led to a 6-year-old child who's got a brain that's not even as well organized as or as functional as a 9-month-old child. Now, what do you do with this stuff? The key is, once you've documented sort of these functional deficits, what does that tell you? What do you do? How do you actually begin to approach these children? What kinds of interventions can you do? And part of what this neurosequential approach helps us do as clinicians evaluating the child is, number one, figure out where the child is developmentally. And then number two, try to put together an array of experiences for the child that will begin to provide age-appropriate but developmentally sensitive interventions and activities that can help these children catch up. One of the inevitable consequences of the way the brain develops is that if there is an early insult, if there is an intrauterine or early childhood insult that influences the development of these lower parts of the brain, it will cause an inevitable cascade of problems throughout all the other parts of the brain, and you'll get this set of interrelated but sometimes seemingly separate problems. And this is illustrated by this graphic that in insult to the brainstem will inevitably cause a shard of dysfunction to go all the way up through all these different parts of the brain. We talked about the molecular mechanism for that involving these noradrenergic, dopaminergic, and serotonergic neurons who have their cell bodies that originate low in the brain and send direct connections up into all these other parts of the brain. So the challenge, therefore, in working with so many maltreated children is, what do you do to try and provide the therapeutic or educational or caregiving experiences that will help that poorly regulated part of the brain change? And the key is this. If you recall what we talked about, the core principles of what makes the brain change. The brain is plastic. But once it's organized, the cortex, the top part of the brain, is much more plastic and easier to modify than the lower parts of the brain. So we have this challenge. A child who gets older than 3 or 4 and has this poorly regulated brainstem, what is it that we can do using our conventional therapeutic approaches that are going to really provide pattern, repetitive, reparative experiences for the brainstem? And I can tell you right now, we don't typically have the tools in a conventional therapeutic toolbox. Fortunately, there are some things that we know. As we talked about earlier, there are already in the brainstem built-in associations, built-in patterns of neural activity that for almost everybody have been put in place in utero, and that take advantage of this somatosensory, rhythmic input and the connection between those and the neurobiological networks associated with being safe, soothed, satiated. No matter how well-intended you are, no matter how caring you are, no matter how smart you are, if you sit with a child who has a poorly regulated brainstem and you try to talk them out of it, it just will be inefficient and typically ineffective. Similarly, if you have a child who you are hoping to teach some social skills, hoping to provide some kind of relationally based interaction where they will build in better regulatory capabilities in their interactions with others, where they will learn a little bit more about what nonverbal cues mean, when they will have opportunities to get some stimulation and build in a capacity for empathy and other important relational capabilities. You can't do it if this child's all tuned up. And what keeps children tuned up, what keeps children incapable of benefiting from cognitive and relational interventions is a poorly regulated brainstem. So historically, the way we've been treating this is with medications. We've been using medications to contain the reactivity of the noradrenergic, dopaminergic, and serotonergic systems, and in many cases that can be very useful. The problem is, it's increasingly the case that we have been using medications in the absence of any relational or other therapeutic experiences that can meaningfully reorganize and reshape the brain. So we use the medications to basically contain these behaviors at the same time that we are not providing the pattern, repetitive, reparative experiences required for them to build in their own capacity to self-regulate. So it's not unusual to see a child in the child protective system who's got a functional brain map like some of those we've seen earlier, who will be put on 4 or 5 medications. And the efficacy of these medications is very poorly documented typically. In fact, the vast majority of psychotropic medications used in children have never been effectively studied in children for either safety or efficacy. So that's a problem. The other, I think, important aspect of psychopharmacology, and make no mistake about it, we use medications when it's appropriate as a meaningful adjunct to the work that we do, and it's been very helpful. However, What we know about medications is this, and we've talked about how neural systems change. They change with repetition. In order to change a neural network, in order to build in new synaptic connections, you have to provide pattern, repetitive stimulation. And when you take a medication, it doesn't provide rhythmic or repetitive stimulation. It is a all or nothing phenomenon. So when you take a medication, for example, like many of the psychostimulants, that increases the concentration of dopamine in the synapse, that will be an increase in the concentration of dopamine in the synapse independent of any other activity that's going on. So it is an on phenomenon, and it will last 3-4 hours as long as the medication is in your bloodstream. So the upshot of that mechanism of action is that medications will be able to contain poorly regulated systems, but medications cannot reorganize poorly regulated systems. So, in order to change any part of the brain, we've talked about this before, you have to activate it, right? You can't build in a motor skill unless you have motor practice. You can't learn how to shoot baskets by just watching a videotape. You can kind of learn how it's supposed to happen, but you will not build in that capability unless you actually hold the ball and try it. You cannot learn how to have healthy relationships by watching videotapes. You can learn some of the rules and some things that might work, but until you actually go out and practice some of this stuff and have real live experience, you will not change the social emotional part of your brain. You cannot change the brainstem by telling kids to don't be anxious, don't be inattentive, stop being inattentive, stop being depressed. Cognitive interventions, and I'm not trying to say that cognitive interventions do not work, but it's a very inefficient way to contain a poorly organized or poorly regulated brainstem. The way you change the brainstem is by providing patterned, repetitive, somatosensory activities that we know will go directly into the brainstem. So what did we say earlier about how the brain's organized? Touch, right? Motor vestibular movement, visual input, auditory input. The first stop for all that sensory input is the brainstem. So if we take advantage of our senses and we provide patterned, repetitive, rhythmic, smoothly regulated touch, movement, sound, we can actually provide organizing rhythms for a poorly organized brainstem. So, if you want to change the brainstem, you have to provide developmentally relevant activities. And you have to provide them in a relational context. The reason it's important that it's relational is that is the most efficient way to get information into the head of a human being. It also has to be pleasurable. If you want to design some sort of therapeutic activity, some activity that's going to provide sufficient repetitions to change the brain, the only way to have that happen is if it's fun. So you have to design some activity that is relational, that is developmentally relevant, that is repetitive, and that is rewarding. And I can tell you right now that you're going to be much more effective if you're trying to change the brainstem if that is also a rhythmic activity. So there are these qualities of an experience that make it much more likely to provide the necessary stimulation to organize the brainstem. This is why when we're talking about children with poorly organized brainstems, we talk about therapeutic massage. We talk about music and movement. We talk about the use of music in other settings where children can have background rhythms as they try to do cognitive tasks. This is why we have children who are 5, 6, 7 years old who sit in class and they may rock themselves and the teacher says, "Don't do that, Billy." And we have to tell the teacher, "Yes, let Billy do that. Let Billy do that. Let Billy chew gum." Chewing gum provides patterned, repetitive, rhythmic input to the brainstem, and there's some really interesting studies that show you now that if you chew gum while you take tests, you have higher scores than if you don't. You can recall information more efficiently. You can store information more efficiently if you are chewing gum. The truth is, you can store information more efficiently if you learn music in song. Everybody learns their alphabet learning the ABC song. So, take advantage of this biological gift. The biological gift is that your brainstem has built-in associations that allow you to quiet it down. If you find patterned, repetitive drumming, patterned, repetitive dancing, music, massage, all of these things go into the brainstem and can provide sufficient repetition for that system to, number one, quiet down so you can then use your cortex, and you can then use your limbic relational capabilities. And then number two, to begin to slowly reorganize and build in self-soothing and self-regulating capabilities.